everybody. I am going to put together a video here to show you guys all of the hardware for the ASEN 3113 Lab 1 Stirling engine. So the first thing that I want to show you is the actual Stirling engine itself. This is a commercial off-the-shelf engine that people buy as a desktop Stirling engine. You put it on top of your coffee mug, and the heat from your coffee mug will create a temperature difference which can run the Stirling engine. We've taken this Stirling engine and modified it some so that you guys can get data. First thing you'll see here is that we've put on an optical sensor. This optical sensor allows us to record data about the position of the flywheel. You'll see that there's a hole in the center of this flywheel. As the hole moves through the optical switch, it will send ones to the computer, and when the hole is not moving through the optical switch, it will send zeros. This optical switch is connected to a control box, which is here, and then that data is sent to the DAC system and back out to the computer. The next thing that you'll see is that there's this blue wire, which is the pressure sensor. It's hooked up to the top of the Stirling engine and outputs pressure data to the DAC system and back out to the computer so that you guys can get good pressure data. We also have a red and black line running here. That hooks up to this red and black line here, which allows current and voltage to run into the resistive heater, which is located on the top of the bottom plate. This is also running through the control box and is hooked up to a 48 volt power transformer, which connects to just a wall outlet, and 48 volts is run directly into the resistor. The last thing that's connected to the Stirling engine is 4 thermocouples. Each one of these thermocouples is connected to a different position on the Stirling engine. One is on the top of the top plate, bottom of the top plate, top of the bottom plate, and bottom of the bottom plate. These give you good temperature data so you can actually tell what your temperature difference is between the bottom and the top plate. All of these sensors run back into the DAC system and out to the computer through a USB 2.0. Before starting any experiment, you want to make sure that your heater is hooked up and that you also have a power supply running so that the optical switch can be recording data. That's all for the hardware setup. Now I'm going to show you how to set up the software on the computer. When you come into lab, you're going to open the Stirling engine LabVIEW file. The next thing you're going to do is set your desired temperature. You can pick a temperature between 8 and 12 degrees. I'm going to run this experiment at 10 degrees. Then you also want to use the drop-down arrow to choose which engine you're using. For this demonstration, we're using engine 3. Each engine has different properties, and it's important that you choose the right engine to get good results. You can then hit the white arrow in the top left-hand corner and save your data to a file. You can choose whatever file name you'd like for this. I'm going to say this is engine 3 test 10 for 10 degrees and hit OK. You'll then see that each of the 4 plots begins to record data. On the top here, you'll be able to see the actual engine temperature difference. Here it's set to 3.4 degrees right now and rising. Once this gets up to 10 degrees, you can start your engine. So we'll wait for that to heat up. On the top left-hand corner, you'll see the pressure plot. This shows you the pressure as it changes inside of the engine chamber. The bottom left-hand plot shows you the 4 thermocouples. You'll notice that the 2 thermocouples attached to the bottom plate are heating up, and that the top plate is basically staying at ambient temperature. As the temperature difference between these thermocouples increases, the actual temperature difference increases, and your Stirling engine will begin to heat up and run. In the top right-hand corner, you can see the current to the heater. This current is recorded so that you can see exactly how much power is running to your resistive heater at any time. This will help you be able to track the heat in to the heater. In the bottom right-hand corner, you'll see the optical switch. When the engine actually starts running, you'll see this switch spit out ones and zeros in a square wave fashion as the Stirling engine flywheel begins to spin. Now that we're up to about 7.8 degrees here, Will is going to start the Stirling engine running, and we can see the data begin to come in. You can see the pressure is changing. You can see the optical switch in the bottom right-hand corner here, spitting out ones and zeros. And the current to the heater is still a constant high value. Once we get up to around 10 degrees, you'll see that this current will switch on and off to try to keep the temperature difference at 10 degrees instead of rising beyond that. Once you get to your desired temperature difference, you can hit this Send Data to File button, and it will send a bunch of samples to your file. You can then hit it again to stop recording data. We recommend that you take about 10 peaks or waves or 10 seconds of data so that you get good results. All right, you can start to see now in the upper right-hand corner as this current switches on and off to try to control the temperature difference now that we're at 10 plus degrees. Good luck with your data.